Another important feature of synaptic transmission is that there is a diffusive component where a presynaptic bouton that's filled with neurotransmitters, of course, releases those vesicles onto the postsynaptic specialized structure and activates ion channel, ligand-gated ion channels to cause postsynaptic potentials, as we've already discussed. But that neurotransmitter will also leak out of the synaptic cleft and go into the extracellular space. And here it can also bind to neurotransmitter receptors, causing distinct actions at a distance from the actual one-to-one synapse. And so there's a highly specific one-to-one communication of synaptic transmission, and then there's a more general volume synaptic transmission where this neurotransmitter diffuses out. Of course, the concentration goes down, and the speed of transmission is also, of course, reduced in this extracellular volume transmission. But it is an important regulator of brain function, and indeed the extracellular concentration of neurotransmitters is likely to have important roles. So for glutamate and GABA, the two main fast synaptic transmitters in the mammalian nervous system, they have this fast one-to-one component, and then in addition there's glutamate and GABA that's present in the extracellular space, and that binds to different types of receptors than are present in the synapse. For yet other neurotransmitters, their only way of function is through volume transmission. And so, for example, at a dopaminergic synapse or presynaptic bouton, there's no postsynaptic specialization at all. And here the dopamine is simply being released into the extracellular space where it can bind to different dopamine receptors that are present on a variety of different membranes. And so there are different forms of synaptic transmission: fast point-to-point chemical synaptic transmission driving the opening of ligand-gated ion channels, and a more diffuse volume transmission that typically operates through other slower biochemical signaling cascades.